Okay, today we're gonna talk about exact equations. One of the methods of finding solution for exact equation is for differential equation is this exact equation. And an exact equation mxy dx plus nxy dy is equal to 0 is an exact equation if and only if when we take the partial derivative of m with respect to y should be equal to the partial derivative of n with respect to x. Okay, so there are actually two methods in finding the solution of an exact equation. So for example, solutions of an exact equation method number one. Number one is you have to test for exactness. So how do we do the test for exactness? We take the partial derivative of m with respect to y, and that should be equal to the partial derivative of n with respect to x. If they are equal, and then therefore it is an exact equation. So after testing for exactness, and we have tested that it is exact, we have proven that it is exact. So we have to integrate partially m with respect to x, taking y as constant. So we take y as constant. And then differentiate partially the result of integration with respect to what? With respect to y. Okay? Taking x as a constant also. So after that, the result should be equated to n. You have to equate with n because technically it should be equal to n because it is an exact equation. And then after that, the result after equating with n, you have to integrate the result after equating with n. After integrating, and then you have to substitute, and you will have your final answer. At any rate, we will take a look on the next example so that you will be able to appreciate more of this method. Okay, as an example of exact equation, let's take a look on this example. So we have this m dx in the format of a differential equation plus n dy. So what we have to do first is we have to test for exactness. So we will do the test for exactness. And how's the process? So the process in tests of exactness is, of course, the partial derivative of m with respect to x, partial derivative of with respect to y rather, is equal to, if this is our m, what is the derivative of m with respect to y? So we have 1, okay? And then the partial derivative of n with respect to x is equal to what? This is our n, and we take the derivative of this one with respect to x, and we take note as y as constant. So this is also 1. So therefore, looking at this example, it is actually exact. Okay, now that we have proven that it is exact, so we have to integrate that one. So we have to integrate the partial derivative of our f, for example, with respect to x, and that is equal to what? This one, m. That should be equal to m. That is x plus y. Okay, so therefore we have df that is equal to x plus y, and then dx. We try to take the integral of this one. What is it? We have f is equal to, what's the integral of this one? That is x squared over 2 plus xy, right? Plus, if we put this, you put our c as h of y with respect to y, and then that is equal to 0, wherein f is equal to 0. Okay, and that is equal to 0. Okay, so what now? After that, we take the derivative. Okay, we take the derivative of f with respect to our y, and that should be equal to n. Okay, that should be equal to n. So what is the derivative of this one with respect to y? Of course, looking at this one, this is already 0. If we put x as a constant, because it's just with respect to y. So therefore, that is what? We have x plus what? H prime of y. If we take a look at this one. Okay? And then that should be equal to n. Equals n. And what is our n? that is equal to x minus y, right? Now, if we take a look, h prime y is equal to, we put this one on the other side, so x minus y, so x and x will cancel out, therefore our h prime of y is equal to negative y. Now, looking at this one, we are only concerned with what is the value h prime hy. So what shall we do? We have to integrate this one. So if we try to integrate this one to get hy, therefore our hy is equal to what? Negative y squared over 2. Did you get it? Now, we have to put it in here already. Okay. If we take the integral of that one, that is equal to h squared over 2 plus xy, minus, what is our hy? Minus y squared over 2, and f is equal to c, okay, is equal to c. And then we multiply 2 on all, so therefore that will be x squared plus 2xy minus y squared is equal to c. So notice, guys, this is already our answer. Okay? So 2c is still equal to c. So this is already our answer. Okay? So we take a look on this example number 2. So if we have here the quantity 2xy minus 3x squared dx plus the quantity x squared plus y dy is equal to 0. So what we will do first is we have to test for exactness. So for test of exactness, we have, let's check if they are, if this equation is exact. So the partial derivative, let's change the symbol. The partial derivative of m with respect to y. So this is our m with respect to y. So what is it? We have 2x, right? So the partial derivative of n with respect to x is equal to still 2x. Therefore, this equation is an exact equation. So let's proceed. Now, we have here now the partial derivative of m with respect to x is equal to m. And that is 2xy minus 3x squared. So therefore, this should be f. Okay, so this should be f. So therefore, our f, if we take the integral of this one, that is 2xy minus 3x squared. Okay, if f is equal to 0, the integral of f is equal to a constant. So that will be what? Take the integral of this one. Integral of that one with respect to x is what? What's the integral of x with respect to, so it's x squared y minus x cubed, right? Plus h, what is it? H of y, okay? And then we differentiate this one. So if we will differentiate this one, okay, sorry, this should be c. If we will differentiate this one with respect to y, that will be, this will be 0, and then with respect to y, that is x squared, right? And then plus h prime of y. Where did x cubed go? So since we are differentiating with respect to y only, So this is considered a constant. Okay, so and then after that, after differentiating, this should be equal to our n already. So that should be equal to n, or what is our n? X squared plus y. So notice there are two x squared in here. So, and they are on the opposite side of the equal sign. So this cancels out these two. So therefore, what happened next is that our h prime of y is equal to only y. And then if we take the integral of this one, okay, to remove the prime, h of y therefore is equal to y squared over 2. And then after that, we have to substitute this one into this equation. So that will be h squared y minus x cubed plus y squared over 2 is equal to c. Now you have the answer. Or you can simplify that further. So we have 2x squared y minus 2x cubed plus y squared is equal to c. So you already have your answer. Okay? So that's another example of an exact equation. Let's continue on. The method I showed you on the first two problems is the first method of finding the solution for exact equation. Now I'll show you the second method for finding the solution of an exact equation. So I intentionally left the answer for problem number 2 for us to verify the answers later. Okay, so let's take a look on this same problem number 2, using the second solution. If we have here 2xy, okay, 2xy minus 3x squared dx plus x squared plus y dy, and that is equal to 0. What you have to do is you just have to integrate everything. Okay, you have to integrate everything for as long as you have undergone the test for exactness, that you have already proven that this equation is exact, so you can proceed with this solution. Okay, what is the integral of this one with respect to dx? So that is x squared y, right? How about this one? We have x cubed. The other one also, we are integrating this one with respect to y, and that is x squared, that is x squared y plus y squared over 2. And what is the integral of 0? That is a constant. Now, let's take a look on this one. What you have to do is, if there are similar terms, you just write once only. So we have x squared y here, and we have also x squared y here. We just write it once. So we have x squared y minus x cubed plus y squared over 2 is equal to c. Now you already have the answer. Okay, so look at the similarity. So this is also the answer on the previous previous solution. Okay. So from previous example, problem number 1, we used a while ago the first method. Now let's take a look on let's verify the answer using the second method. So for method number 2 solution, method number 2, so how should we do it? We have x plus y dx, right? Plus x minus y dy is equal to 0. Supposedly the answer should be this one. And then we have to integrate m dx and then integrate n dy, and we have to integrate also 0. So with respect to x, what's this? We have x squared over 2, and then y dx is plus xy. How about this one? X dy. So we also have xy and then minus y dy. Y squared over 2, and that is equal to, what's the integral of 0? We have a constant. Now, which term is the same? This one, right? So therefore we have x squared over 2 plus, we only have xy minus y squared over 2, and that is equal to c. So take a look on the similarity. This one and this one is the same. Okay, so that's how easy solving an exact equation, for as long as you have proven that it is already exact. Okay, using the test for exactness.